Artificial intelligence is the development of systems which carry out tasks that normally humans are meant to do. To build artificial intelligence systems, we take an input and then, based on a set of rules which have been predefined, we are able to obtain the output. This way of telling a computer based on a set of rules to produce a given output is known as symbolic artificial intelligence, short form symbolic AI. This kind of AI was very popular in the 1950s going up to the 1980s, especially in the gaming industry, as we could define a set of rules such that when given as input the current positions of different pieces on the chessboard, the computer is able to decide on the next best move, which is the output. Apart from symbolic AI, there are other branches of artificial intelligence, and one of them, which has become very popular in the past years, is machine learning. In machine learning, we have a model, and with this model we pass in input and output. So notice the direction of the arrows here. We have this two getting in, unlike here where this gets in and then we have this output going out. So here we have firstly this input and this output, which is what we'll call a data set, given that this is data from which this model learns the set of rules which with symbolic AI we actually define. So with symbolic AI we define those rules by hand, while with machine learning these rules are automatically learned by the model itself. And once these rules are learned, when given a new input, we use this learned model to give an output. Also with machine learning, several branches exist, and one of them is deep learning. Deep learning is a branch of machine learning which makes use of neural networks, which can learn from very huge data sets going up to billions and even trillions of data points, and can solve problems in computer vision, natural language processing, speech recognition, and in many other domains. Machine learning, just like deep learning, can be broken up into several parts: supervised learning, unsupervised learning, and reinforcement learning. What we just demonstrated here was supervised learning, in which we have some input data, that's this input and this output from in our data set. Our model is trained, or our model learns from that data set, and then later on when we need to solve a problem, we pass in the input, and that learned model now is able to generate an output based on this learning or based on this previous learning process. A simple example could be in object detection. We could pass in input data or input images, and they are labeled outputs. So we could have an image which contains a cell phone, and then the output is labeled such that the model knows that in this image there is actually a cell phone. And then once this model is trained over thousands or even millions of such cell phone image and output pairs, now when presented an image in which there is a cell phone, the model is able to say that there is a cell phone in that image. So that's supervised learning. As the word goes, the learning process is supervised since we have the input and we also have the output. And so the supervision is done by the fact that when, for example, we have an input image containing a cell phone, the output clearly states that there is a cell phone in that image. The next and most promising subsection is the unsupervised learning. In unsupervised learning, the model learns from just the inputs, so there is no supervision, there is no outputs. We just pass in the input, the model learns, and then Next, and when we pass the input, the model is able to generate outputs based on this learned model, which took only the inputs. We see that there is a limitation with the supervised learning method, because with supervised learning, we have to get the inputs first, and then we also need to annotate and say that this input, for example, contains a cell phone, this input doesn't contain a cell phone, and so on and so forth. But with unsupervised learning, we just simply pass in the inputs and the model learns. So we see that if we are to build a system which works on real data, we will be able to do that quickly and more efficiently with the unsupervised learning technique, since we don't necessarily need to annotate every input. A clear example of the power of unsupervised learning was shown recently with the paper which used unsupervised learning to train speech recognition models. Now, in speech recognition, generally we have the data such that we have the speech, that's the actual sound signal, and then the output is a transcription. So the model is going to learn how to get this kind of sound signal and then output the right transcription. In a language like English, it's very easy to have or build such large data sets, since there are billions of people who speak English around the world. Now, what are those languages in which gathering such data is very challenging, like say Hausa in the northern part of Cameroon or Oriya in India? This becomes challenging as getting the right annotations isn't very easy. So if we have a kind of learning system in which we just simply pass in the inputs and the model learns, then that's perfect for such languages, as all we need to do now is to allow people speak, and then the model learns how to do the transcription automatically without necessarily having the input signal and the output transcription during the learning process. The other type of machine learning is reinforcement learning. To understand reinforcement learning, we are going to consider an environment, an interpreter, and an agent. The interpreter gets information about the environment and then passes it on to the agent. And then the interpreter rewards the agent depending on how well it took this action. And so at the end, we have this agent which is learning how to take the best actions since it's been rewarded by the interpreter. A simple application of this could be in the chess game. So our environment is a chess board, and then we are trying to train this agent to make the best moves based on the current state of the environment, and also using the reward system from the interpreter. The reasons why machine learning and deep learning, to be more precise, has grown in popularity in the past years is because, firstly, there is availability of this training data, and this training data comes from many sources on the internet. We have Wikipedia, YouTube, and Twitter, which are just a few of the thousands of web pages and applications from which users input data every second. And since this machine learning models feed on this data, it becomes obvious that the availability of such data has made the machine learning field very popular. Nonetheless, it should be noted that when working with classical machine learning algorithms, as we increase the data, the performance starts to stagnate at a certain point. And that's where deep neural networks come in. It happens that with deep neural networks, as this data increases, the performance too increases. And that's why the neural networks have received so much attention lately. The next reason why machine learning has become a hot topic is because of the availability of hardware, especially the GPUs and the TPUs. GPU actually stands for graphical processing unit, and TPU, tensor processing unit. These devices, although previously known for their use in the gaming industry with the GPU graphic cards, now actually have great use in machine learning. Reason being that many times we are training our very deep models on very large data sets. By deep, we simply mean if we have this model with, let's just take this as inputs, and then here we have outputs. So this model has 3 layers in between. This is a layer, or we could say this is a layer, this is a layer, and this is a layer. This is the input and this is the output. So with this 3 layers, which we call hidden layers, we would say this neural network is shallower compared to another neural network with 20 of these hidden layers. And so by deep, we are meaning the amount of hidden layers which is stacked. Now coming back to the GPUs, training such models are very computationally expensive. And so if we could make use of the parallel nature of these computing devices, it becomes interesting in the sense that we can now parallelize the training process and hence speed up this training process. Apart from data and hardware, the other point which makes machine learning very popular today is the advancement in the kind of machine learning and deep learning algorithms which have been built. And throughout this course, we shall look in details these algorithms.